This is a screencast by Thomas Vines for CA1 in client-server distributed programming. First of all, we have the problem that we have to do. We have to design and implement and test a client-server messaging application using Java sockets. It has to allow clients to send messages to more than one user at a time. Message sending has to be asynchronous, so delivery is independent of the sending, so that when a client sends a message, they're not blocked while they wait for the receiver to get the message. Clients should be able to receive any message sent to them since they were last logged in, and by doing this, that will also mean that once they receive messages, they will be deleted off the server once the client confirms that they have received the messages. And to allow multiple clients to connect at once, the server will have to use multi-threading. Here we can see the Java sockets. The server uses the server socket class, and it basically listens on a specific port number. So when you specify a port number, the server will listen through the socket on that specific port number, waiting for clients to connect. The clients use the socket class, and when they want to connect to a server, they need to specify the server's IP address and the port number to connect to the server on. So when the clients input this information, they can then create a connection to the server, as you can see in the diagram there. To allow for multi-threading, the server will generally, if it's set up, it'll just listen and just create one thread, but it has to implement multi-threading in order to allow multiple clients to connect at once. There's just a basic picture of how threads kind of work in the diagram there. Each client will connect independently on its own, and they'll think that they're connected to the server just by themselves, but the server will be dealing with multiple clients at once through the use of threads. Asynchronous sending is used by the program, and by that I mean message delivery is independent of the sending. And a simplified version of that means that the sender does not have to wait to see if the recipient received the message. In the diagram below, we can see that client A has sent a message to client C, but client C is not connected. So when client A sends the message, the message is held on the server, and it will be held there until client C connects to the server next time. And when client C does connect next time, it can then receive the message from the server, and by this the messages are sent asynchronously. The program can also let a client send a message to multiple clients at once, and in the diagram below we can see that client B sends a message to client A and to client C. Client A is already connected to the server, so when client B sends a message, client A is able to receive the message straight away. Client C, however, is not connected to the server and must wait until it reconnects to the server in order to receive the message. During this project, we kept client-server aspects in mind, but in reality they were the last things that were actually thought about. We decided to work on common aspects in the project first, which were the streams, and then there was a number of plain old Java objects, which were the message, message parsing, and user details. These are classes basically that were common to both the client and server, and they were stored in the utilities package. As you can see here, these are all of the Java class files that were used and the packages they were stored in. The utils file are shared between the client and the server. The test files were basically used to test the POJO objects. the server package contains files that are used by the server only, and the client contains files that are used by just the client. Streams are used by both the client and the server to communicate with each other across a network. The stream socket class extends the socket class, and it contains two constructors. The server uses one constructor and the client uses the other constructor. The server constructor just takes the socket as a parameter, and this is when the client connects to the server. The server then passes that connection into the stream socket so that they can both communicate with each other. The client takes an internet address, which is the server's internet address, and it takes the port number, which is the port number specified by the server. And this is what it takes as an input in order to connect with the server and communicate with it. The class contains three methods. The setStreams method, which creates the buffered reader and the print writer. It also contains the send message, which the print writer uses to send messages across the network, and the receive message method uses the buffered reader to receive input from the stream and display it as a string to the user. The message class in the utils package is one of the most important classes in the program. It is used to send messages from the client to the server, and it defines the specific format that is used for each message. As you can see in the picture, this class contains 4 variables. The string from, which defines who the message was sent from, an array list of strings called to, which defines who the message is going to be sent to, and as it's an array list, it can contain many recipients of a message. Time sent is basically a timestamp, and text, which is the actual message that is going to be sent. The message class is vital to the application and is heavily commented to make it easier to work with. The class became a bit bulky, with some of the methods being not utilized in the final product, but as it is a pivotal class, most of the methods are extremely important. The method addTo in the message class is important as it prevents duplicate entries being added to the to list. This means that if a recipient is accidentally added twice when a message is being sent to someone, the message class will only add that recipient once instead of having multiple entries for that person. Users are allowed to address a message sent to multiple users using a comma as a delimiter. This method uses the tokenizer class to break up the individual users by using that comma delimiter. It then uses the addTo method, seen here, to add them to the array list and make sure there are no doubles involved. The send message as XML string basically does as it says. It takes a message and it puts it into an XML format, which can be seen here. It also has this other small little if statement within it, which makes sure that when a message is sent, a timestamp is added to it. So when the client sends a message, they will affix a timestamp to a message, and this will then be sent to the server. When the server uses this same send message as XML string to send a message to a client, it will know that a timestamp has already been added to the message, so it will not need to add one itself, as it will already have been added by the client, so the client will know what time the message was sent to them at. This is just a small method that takes the recipients of a message, as there can be many of them, and it puts them into the XML string as well. This is the method that is used to get the timestamp for the message and before it is added to it. The XML parser is another class that is used in the utils package. It is able to extract the data from an XML string and parse it into a message object. It takes an XML string as a parameter, and it uses the public static final strings defined within the message class in order to get the XML tags and to break up the message. And it will return a message object with the parsed data inside the object. This class can be used by both the server and the client. The final class in the utils package is the user class, and it has three variables: string username, string password, and an array list of messages. The user class contains a relatively small number of methods compared to that in the message class. The add message method allows a message to be added to a user's account. It checks that the message is unique first before it allows it to be added. The getMessage method allows for messages to be gotten from the user's account without another object actually getting reference to the array list of messages. The equals and hashcode method for the user class were altered so that it would only use the username of the class as a check for the object being equal to each other. By doing this, we can ensure that usernames are unique, while passwords and messages can be anything. To proceed next, we decided what the interface should look like, as this would give an idea of what messages would need to be passed between both classes, between the server and the client. As the server did not need an interface, system.out.println statements were used as a method for just displaying the calls that were being used on the server. The client did need an interface to display to the user, and I will show you that next. This was kind of an original mock of kind of what we thought the client would look like. The client would enter a server IP address, or if it was left blank, it would default to localhost. They'd enter a username and their password as their login details, and this would loop around until they entered a correct username and password that the server knew of, and would display a success or error message depending on that. And then it would display the main interface to the user, which would be allow them to retrieve their messages, send a new message, or exit, and the user would enter their input of 1, 2, or 3, and this would be constantly looped around until they entered the correct number. The actual interface, when we completed programming, was slightly different. We added in, at the start, they connect as normal. They can enter the server IP address, or it'll default to localhost if nothing is entered. They'll get a message saying they're connected, and they'll then have to choose an option. Would they like to log in with an existing account, or we can go create a new account for a new user, and they will enter 5 or 6 depending on which option they select. And as you can see here, if they enter 5, they will get this type of an input, and if they enter 6, they will get this. And basically, whichever option they select, it will loop around through that particular option until they enter the correct details. That concludes this part of the screencast. If you click the little next button that's on the screen, you can see the next part.